Benissimo, benissimo. Allora continuiamo perché appunto siamo un po' fuori tempo. Diamo subito la parola al professore. Sì, sì, che oltre a essere il direttore della cattedra. Mi hai tolto il microfono.
Oh.
E allora, giusto per presentarti, sei anche un docente, sei un nostro docente in ontologia razionalità scientifica. Lui proviene dagli Stati Uniti, no? Ha studiato matematica, un dottorato in matematica all'Università della California, ma poi ha integrato gli studi in ambito teologico e quindi appunto ha studiato presso l'Università Cattolica Teologica, dove ha preso un Master of Arts in teologia sistematica. E ha combinato nella sua vita questi due aspetti, l'aspetto appunto scientifico e l'aspetto teologico, raccogliendo poi diverse espressioni anche su varie università. Io ti lascio qua, non voglio andare oltre perché altrimenti occupo tempo, va bene? E ascoltiamo volentieri anche il tuo intervento poi.
Okay. For those who, is the translation working at this stage? Can you hear me in Italian? Has it been translated into Italian? Okay. I don't know if it's Lamberto at this stage or Lydia, whoever. Anyway, anyway, yeah. My presentation. Can you put it up on screen? Is do robots think like we do? It's very much in keeping, I'd say, continuation of what Manuela or Dr. Velosa has said. In fact, we didn't speak to each other about her topics at all. I had no time to share what I was going to say, nor she with me. Yet you'll see quite a bit of overlap. But I will take it more in an epistemological way. In other words, I really want to hone in, what does it mean to think? I think that's the key to understanding what differentiates us from humans from robots or machines. So do robots think like we do? So first of all, computers and robots personified. You know, Manuela already made an emphasis and correctly that robots and computers are just machines. But if you look at some of the movies throughout Hollywood history, beginning right back in 1959, there was I always remember as the first TV sets in black and white was this Twilight Zone that I started watching. And I always remembered this one that was fascinating. It's called The Lonely. And it's a simple story. It was only a half-hour program, black and white. But the story is of a convict who has been condemned to solitary confinement, basically for life. And the solitary confinement wasn't to be put in a cell. It was sent to an uninhabited planet, and he had to live his life out on a planet by himself. And of course, once a year, a rocket or a spaceship would arrive just to check out to see if he's still alive and maybe give him the minimal of assistance with certain things to help him survive. He had the whole planet to himself. It wasn't that he was locked up. And the thing that came across from the title, The Lonely, was this horrible loneliness of being alone. And one day, the spaceship captain announced that, well, look, I got certain privileges for you. We're going to give you a robot, a companion robot, a female robot, just be programmed all for you, and do whatever you like with her. You know, I mean, she has to be programmed. So essentially, that's what he does. He has this beautiful robot, and she's programmed, and she corresponds to him. And it's only 25-minute program. There's even so then the next few minutes later, the rocket reappears another year later or 2 years later and says, we got great news for you, Charlie. Let's call him Charlie. You got a reprieve. You don't have to spend your life anymore in solitary confinement. We have rumored that you can come away with us now. And he says, but I want to take, he calls her, he had the name for, let's call her Eva, but I want Eva to come with me. And he said, who's Eva? But she's my companion you gave me. No, that's a machine. No, I cannot go without her. And when he said, well, we can't take her because we don't have enough payload weight to take her. There's only room for one person. She has to stay. It's only a machine. Don't worry about her. And the bottom line is he won't go because he's fallen in love with his robot. So that was 1959. The same theme as humanizing computers has come true. If you've seen 2001: A Space Odyssey, which I think is one of the best science fiction movies ever made, HAL, which actually represents IBM, moved one letter to the left. 1968, again, the rocket ship is everything. The HAL is the spaceship, rocket, everything. It's all controlled by HAL. And it becomes very personalized, because when he picks out that there's this, one of the astronauts sees something that's a glitch in the computer program, a glitch that he shouldn't have made, decides to investigate it. HAL goes on the defensive and basically tries to defend himself and eliminate the humans who could be possibly trying to destroy him, and so on. And we go back to 2013, there was this movie came on again, the picture of a man who fell in love with his computer. It would have a nice feminine voice like Siri or whatever. And she's called in English her, I think in Italian lei. So this is a theme that's probably at the basis of a lot of what we call transhumanism, that somehow robots or machines are going to somehow become like us or even better than us. Okay, so just to let you think. Now, definition of transhumanism is, Manuela actually said there are many definitions. It's hard to give any real definition in social sciences. I'm a pure I studied mathematics rigorously, and the nice thing about what makes math easy, and I've always liked, is you gave a definition and you worked with it. You knew how to derive the stuff from the definition. In the social sciences, definitions are heuristic. In other words, there's no real clear concept of what you mean. You have a notion of an unknown that somehow will become known when you arrive at it, heuristic. In this case, it's a belief or theory that the human race can evolve beyond its current physical and mental limitations, especially by means of science and technology. Now, already the word evolve would be a huge problem. How can you evolve beyond yourself? If beyond yourself, you're no longer you. Just think of the problem. If you are beyond yourself, you're no longer you, you're something else, you're gone. So you don't really want to evolve beyond being human, because you won't be human anymore. Think about it, bad problem. So even the wording there is out epistemologically, but most people would think that way. You see attempts at this with Cortana or Alexa. You may have Alexa in your home. If you haven't, it's a treat. You know, you have this device in every room, and you just say, Alexa, what's the time today? Alexa, what should I wear? Alexa, what's the weather like outside? And you get this programmed voice that will respond to you. And basically, Alexa can switch on your electricity, turn on your TV sets, run the refrigerator, run everything if you let her. I called her, but if you let it, right? That's just the beginning of something that you might consider at the beginning of a transhumanism. So another interesting thing is a journal called Artificial Life. I was at UCLA studying mathematics when right next door to me, basically 50 yards away, was the whole computer science department. And on the floor, I was at my office. They were literally working on artificial life in the 1980s, and then they brought out a journal in 1993. Now, what is artificial life? Well, they have a definition here, but in those days, it was a computer, large computer, being programmed to simulate or imitate life. I know what you would call it, called simulate, imitate, or it is life. For me, it was just a machine. But people who get into this material, really, people who get into it, after a while, lose the distinction between simulation, image, and the real. It's very interesting to watch. I remember speaking to one of the programmers and was convinced, but really is life. We're doing what life is. And I'm saying, look, you can't even produce a water molecule. Don't tell me you could produce a living thing. And, you know, for me, a computer, for example, a water molecule, can it be simulated by a computer? Well, my point of view is if I can't embrace a computer and feel wet, then it's not water, it's something else. The same way, if I can't embrace the computer and get a hug, it's probably not human or a life that I'm interested in. I don't know if I'm communicating the problems. So back to Alan Turing. She mentioned him. Alan Turing was, as you know, in the famous book, The Imitation Game, and he worked on this called The Enigma, which you've probably seen in the movie, where he helped crack the German code during the Second World War using a computer and machine. He had to invent it. Just to give some credit, the Polish scientists had already had a major step in cracking the well before Alan Turing. In fact, if it hadn't been the help of the Polish scientists pre-Second World War, he wouldn't have been able to probably make it as quickly to actually crack the Enigma. But anyway, Turing, as mentioned, considers the question of whether a computer can think like us. For Alan Turing, that question was meaningless, and I'd agree entirely with him. So he turned the question around. And the question is instead, he suggests an alternative question. Is it possible to have a computer respond to questions asked by a human being such that we cannot distinguish it from a human being? So imagine you have one of the robots she just showed you outside the door, and you start asking questions, and it starts giving you answers. And the question is now, from the questions and the answers you've received, is this a machine or human? That's the question. Alan Turing would say, when you get to a stage that you cannot distinguish, then the question becomes a moot point. That's the Turing test. Okay, let's talk about it. So, as I said, I didn't speak with her, just coincidence. Let's start with the Kasparov game, and Garry Kasparov's game with chess and Deep Blue. What she didn't mention, and this gets much more interesting, Deep Blue made 200 million calculations per second for every move it made. 200 million calculations a second for every move it made in chess. No human being ever could make 200 million calculations a second, and Kasparov didn't make any calculations. Right? Now, the Deep Blue did win the tournament 3.5 to 2.5. In chess, if you win, you get 1. If you lose, you get to 0. And if it's what's called stalemate, you get a half, 50-50. So for the multiple games, you can work, I don't know how many games were 12, 3 to 5, what's it, 11, 22 games, whatever. At the end, the computer Deep Blue won. However, think about the difference, 200 million calculations a second to play a game of chess. No human being plays like that. So in other words, the computer, even though it's beating Kasparov in the game of chess, is playing according to a very different set of rules. And that's the point. There's another thing between, man and the machine, or a person and a machine. In June of 2014, in Odessa, Ukraine, which now is in war, they invented what they call a robot, a chatbot, which you now find, by the way, if you ever want to book a ticket on an airline and you have a question, it's a chatbot's responding to you. I found that out 3 weeks ago trying to change a ticket. But anyway, a chatbot was made, and it was able to convince 30% of those asking questions in a conversation that lasted 5 minutes that he was a boy of 13 years. So you could say, so the Turing test has been successful. There are many restrictions here. First of all, a boy of 13 years is not rational. And that was the point. How would you decide it's a boy and not an adult? Secondly, you're limited to 5 minutes. And thirdly, I think if you ask just enough questions, you will find that he wouldn't have any idea what you were talking about after a while. You know, maybe just suddenly ask him a lot of intelligent questions. Say, oh, by the way, would you like an ice cream? Or what did you think when you're flying over the Grand Canyon, as she would have asked? I think you'll find those questions would suddenly get very confused by the computer. So even though 30% might have thought that they were dealing with a human being, I just think it's not even worth asking the question almost. You know, Eugene Gussman is not human. But let's again pose the question, why? How would you recognize it? Obviously, Turing just wants his test, questions and answers, but it has to be more than just question and answer. So the question is, who are we? Who am I? First of all, the question who is not a what. Each individual is aware of their identity. What is a computer is not who is the computer. Ultimately, I can give you the simple answer is one sentence. When the robot wants to commit suicide, then you know you have a problem. Okay? Or when a robot wants to see his counselor or a psychiatrist or psychoanalyst, then maybe you have a problem. Or whether, so there's something essentially intrinsically different between what we mean by a robot, a computer, and a human, just in how we ask questions. And maybe that's the thing to remember. It's in how we ask the questions we're different. What does it mean to think and to understand? As I just mentioned, Deep Blue made 200 million calculations a second while playing chess against Kasparov. Instead, here's the point, Kasparov responds responses require the combination of insights and habits. That is eureka, I got it. Oh, that flash physique that just comes so quickly that we grasp when we're studying intense problems is the key to being maybe human, that no computer has. You won't get it having insights. Everything that was pointed out to you earlier was based on mathematical calculations, mathematical algorithms. There wasn't one suggestion that I understood. He certainly did not do calculations. Can a computer have consciousness and awareness of self? That's the question. And now, since we are here in a school, a Christian school, but it would be, you can ask this of being a Buddhist, a Hindu, even agnostic. What is fate and how do you recognize it? Does fate have anything to do with it? I mean, do we ever think that if a robot has a crisis, would it have a crisis of fate? What's the meaning of my life? So if those crises are not happening in a robot or a computer, you're certainly not dealing with anything that's even semblance of being human. And we use the word to simulate, the robot will simulate us in how we move and how we calculate, but simulate doesn't mean equals. It's not essence. The simulate means just imitation. It doesn't mean being the same as. So having said that, maybe with some operative principles, how much time do I have? I'm trying to speed things up. First of all, Aristotle had a nice operative principle already back in 300 BC for Christ or Common Era. The whole is more than the sum of its parts. Maybe that's the first point that we should start recognizing. I'm going to try and help you to understand how things jump from one level to another, that you can't just handle all in a reduced form. There tends to be actually two schools of thought in most of what we're looking at. There's a very positivist outlook that comes from the French Revolution and onwards, where basically the mathematical sciences and physics become the queen of the sciences and the queen of knowledge, if you like. And when one is into a positivist mode of thinking, one can very quickly slip into thinking that the more sophisticated you are mathematically and the more programmable you are mathematically and the more you can solve mathematical type problems, the more intelligent and the better you are. However, that's a very reductionist view of reality. So let's see if we can try to grasp that the whole is more than the parts. And you can, more than the sum of its parts. Take the building blocks of Lego there on your left, and take or if it's not Lego, a piece of mechanical toy, it's a toy, and look at the building on the right. What's the difference between the two? They're both made of the same material. On the left, you've got the box of blocks, and on the right, you've got the same set of blocks, but you also have that looks like a castle. So what's changed? And where did the castle come from? Well, first of all, it's architecture, right? There's a form, what even people in philosophy would call a form. You've given an intelligibility, a construction to those blocks that you recognize a new thing. You could say the construction is made out of blocks, but I wouldn't say the construction is just blocks. It's blocks plus the idea of the person who constructed it brought together in a real act. It's not just even abstract. You've actually got a construction in front of you. If there are real blocks, you can build a building like Sophia. So that's something very fundamental. Okay, so the whole is more than the sum of its parts. Water is another example. For example, water is H2O, meaning what? It's two molecules of two atoms of hydrogen, one atom of oxygen. It comes together and you get water. Now, if any of you studied any basic chemistry, you know that hydrogen by itself is anything but water. It's a gas, you can't see it. In fact, if you light a match, the gas will go on fire. Not the match will fire, the gas itself will permeate the room. The flame will go to the room. Oxygen, on the other hand, if you light a match, will just cause the match to glow very strongly. But neither the oxygen nor the hydrogen is water. In fact, there's no semblance of water in any shape or form. They're not even liquid at room temperature, they're gases. However, if you bring the mixing together, even the mixing per se doesn't do it. You need the spark. As soon as you just do that with a match, boom, you'll get a huge explosion. Oxygen will explode for the click with hydrogen, and you just get a drop of water. So suddenly we've gone from components to something new, which we call water. The whole is more than the sum of the parts. I've worked on this. I have to give a talk in a few weeks in actually Prague, and my title will be Entanglement and Microcausality. Can I reduce chemistry to physics? And the answer is no. There's a lot of things nowadays about quantum entanglement and quantum computers, and it's actually tied in with the fact that this phenomenon called entanglement, which would be worth a couple lessons in itself, really transposes us, moves us beyond strictly the physical laws into the chemical laws, even though you can have entanglement strictly without chemistry. We're not getting into it, but basically the stability of chemistry requires entanglement, and the entanglement requires chemistry to last long. So that mutual relationship between them. So again, new forms and new laws. Your DNA, is DNA really life? I'm always amazed every time I look at a newspaper nowadays, especially popular stuff in science. We found symptoms of life on planets, or the signs of life on Mars, which you found is some basic organic molecules which permeate the whole of matter. So who cares? I mean, give me a break. So what? So you remember, pieces of organic molecules is not life. And even if there is life, you get to pre-life would be viruses, and maybe get to bacteria or amoeba or something similar. That's a long way from anything like human life or even animal life or even plant life. So again, a lot of cliches, a lot of meaningless expressions. The stars are the laboratories for creating complex, for both the atoms and the molecules, right? So DNA is not an amoeba. Amoeba has DNA, and it functions using regulating DNA in terms of biochemical laws. But to define an amoeba's DNA would be a big mistake. That's reductionism. Consciousness. So let's get to what is consciousness. What can we have a working definition? It's first of all, I'm just trying to suggest consciousness is not something that computers or robots would have. Although if we go back to the movies that I suggested, like She or The Lonely, the whole point is there they have produced robots who starts imitating human beings, male or female, by the way. It's also interesting that the sexual difference comes in. But in reality, they're not. There's nothing there in what Manuela would have shown you that would suggest anywhere there's consciousness. What do we mean by consciousness? Here I'd like to follow maybe my principal author would be Bernard Lonergan. I should have probably referenced him, but I always like Lonergan's definition of consciousness, which I think is a fantastic way. At least it's functional. By consciousness, we mean an awareness immanent within cognitional acts. Okay, it's not understanding, it's awareness. Everything you do, you're aware. I'm not saying you understand being aware, you're aware. By the way, also dogs and cats are aware. Well, let's talk about different levels of consciousness. So by consciousness, I mean an awareness immanent within cognitional acts. There are 4 levels of consciousness, at least, which can be associated with specific types of awareness. The level of common sense. And in fact, that was what I would think Manuel was getting to with the computer, the robots. Common sense, we know exactly, like I was flying, what was it? I'm in flying. I flew by the Grand Canyon on the way to New York, or I flew by the Concorde, or the Concorde flew by on the way to New York. There were 2 totally different phrases. Common sense, we know exactly the difference. You just immediately have the Grand Canyon. There's this huge hole in the ground. I've been there a couple of times. It's huge. You'll see it's like a huge hole in the ground. It looks, I mean, stretches for probably 100 kilometers. And the Concorde, I also saw, it was a very small, fast-moving jet. We can distinguish very quickly on the level of common sense that no computer can, or robot. How do you give common sense to something? You can't program it mathematically. That's the problem. Common sense, by definition, is not mathematical. If it were, it wouldn't be common sense. In fact, it's worth a study in itself, but let's leave it at that. The theoretical level, now that's where the computer is functioning at, the eureka moments, but the computer's theoretical moment is really just algorithms programmed into it, programmed by human beings who had the eureka. I know how to program this. I know how to solve this problem. I communicate through my eureka moments, a written mathematical algorithm to the computer, which gets it to function and solve problems in a very real way, and better than us in certain ways, right? And that's what complements us. We can do things very fast. But I'll call it the theoretical level. And then you have what's called the level of interiority, which is what I'm really trying to do, which now I'm pushing you into the interiority. We all have self-reflect. Who am I? What is the meaning of my life? Where am I going? That's something, where does that question come from? And that's the mystery of who you and I are. Where is the question coming from? And until you can, and until you can ever communicate that question to a computer robot, the question of whether they will be human or not is really a meaningless question. And I think Turing at least got that point, okay? And then you've got the whole level of responsibility. When you do grasp the amount of interiority, which nowadays in many cases, I think, especially in the Anglo-Saxon world, it's a question we've killed because we put a huge emphasis on the technological, and that's probably why the Anglo-Saxon world is much more advanced technologically, or gets things done a lot more efficiently, I would say, but it doesn't spend much time emphasizing the interiority. And it's tragic because we need to rediscover an education system that puts emphasis on the interior question, a question of meaning. Why am I here? What is the meaning of life? I'm not out to give you answers. I'm out to me, the most important thing is that the question becomes important. Once the question is important to you, then it's up to each one to start discovering their own answer. And then the level of responsibility, because once you find that, you're also responsible. Are you free to do anything you want? Are you really? If you're wishing somebody drowning at sea, you can say, oh, yeah, they're drowning, you just continue on your way. Maybe you feel obligated to help. Where does that come from? So level of responsibility. So a person might also transcend these levels and also move into a horizon in which they experience, let's say, love of God. Or you could be a Buddhist. I mean, just think of the idea of Buddha, Prince Gunyama, who spent his time under the Bodhi tree until enlightenment. Why did he have to sit under the Bodhi tree until he was enlightened? Again, the issue there, the desire for meaning that was well beyond anything that was a computer. So at the end, there are two approaches, and that's the two approaches are really two different paradigms, and they're clashing, I would think, very much in our day, and it could come to the fore. Are we here because our number came out by chance in the game of cosmic roulette, as Jacques Monod claims? Jacques Monod won the Nobel Prize for, I think, in 1961, I'm corrected there, for biology, a French biologist. And he claims he's a strict Darwinist. So he claims our number came up by accident. I have the book actually, ironically, in Italian. I haven't had any, so I just put the Italian title, Il caso alla necessità, cause and necessity. Or are we here, and here I am as a Christian or as a believer, or are we here because God knows how to play with dice? Einstein made a famous statement, God does not play with dice. I think he knows how to play with dice and plays it very, very well. Is consciousness a natural or supernatural phenomenon, or both? I'll just leave it to questions. So here I put a Christian thing in, but I'm not trying to impose Christian terms on anybody. One can also, as I said, maybe if you're a Buddhist, think of the Bodhi tree. But here there are two different paradigms really come out. Here we touch upon the great divide that separates the modern reductionist approach, which is essentially we build up from a mathematical construct of the world to physics and chemistry, and also believe that it contains all the answers, or a Christian approach where vision, which is somehow based on faith. Now it said faith, not morality, faith, which is something that's hard to define. Lornick would call it an otherworldly falling in love. So let's just move on there with that. So 2 points of view then. There's this real dichotomy in our time. The reductionists, I won't say scientific method because I consider myself a scientist too, but is strictly only allowing for a mathematical, physical approach to solving problems, or what has given meaning, which really quenches the meaning. You don't allow for the questions and meaning to come out. This comes out in a very, I would say, satirical way by a book by a great American author I like, North American author Walker Percy from the United States. He has a book called Lost in the Cosmos, and it's a person who's lost in his own cosmos. This is a great challenge at the heart of postmodernity. On the one hand, it can be described as an epoch where the person is lost in the cosmos, to use the expression of Walker Percy. Or on the other hand, it's an epoch in which scientific method is rejected as an absolute and seeks a new synthesis based on fate. That, you know, the whole postmodern reaction came out in the, because say early 20th, mid 20th century as a reaction against science. It didn't want the scientific method per se, wanted something more, but so it's postmodern. But the problem with postmodern, if it doesn't have some type of fixed point, if you're a physicist, or an absolute or a fate, it kind of lacks direction. At the end, anything goes. My opinion is equal to your opinion, and everybody's opinion is equal, which I just don't think is actually true. Are all opinions equal? I'm not too sure. Just think if that's really true, then why are we upset with Nazism? Why are we upset with Marxism? Why are some people upset with abortion? Well, you know, obviously not all opinions are equal. Why are we trying to change the economy? So there must be something that's in some fixed point, an invariant that allows us to make some type of value judgments that we're holding on to. And I think fate would have something maybe to do with that, but it's not fate in itself, okay? But there's the two paradigms again. So let's go back to the imitation game. A human being is conscious, an artificial life is not conscious. So there's your paradigm. In the human being, you have perception, common sense. Dogs, cats perceive, we perceive. I could talk about this for a long time, no time. Let's let it go. Theory means having insights. I've discovered quite a few mathematical theorems, and every theorem I've discovered, I've needed an insight. And then I can work out a theorem for all the conditions and prove it. But all those conditions and proofs rest on one thing. I got an insight. Theory means following mathematical algorithms. Now, algorithms means I programmed it, but the algorithm is not the insight. Okay, there's a difference. Interiority is the quest for meaning and authenticity. In the machine, there is no interiority. Responsibility comes with being human. Computers have no responsibility, which goes back to the question that Manuela was just asked. It's we decide how the machines are used. And then otherworldly falling in love. The computers, robots, really, I don't think there's any quest for the transcendent, for meaning beyond this. Okay. I'll skip this. For example, I would even argue Neanderthals and humans would be worth comparing. Well, we won't go there. Let's go. Just a couple of questions. So what's missing then? Can we re-summarize, capture it all? St. Augustine makes a very famous saying, you made us for yourself, O Lord, but even if you don't want to be, and our hearts, look at the word heart, and our hearts are restless and they rest in you. Take Blaise Pascal. The heart has its reasons that reason cannot understand. So there's something else happening. Their heart has its reason that reasons cannot understand. And then in honor of Piero Pasolini, whom this Cattedra is dedicated to, I just read, and perhaps, something I found last night, I just translated, and perhaps that moment of evolution has arrived, that famous evolution of which I speak, in which I say, but in the end, will human evolution fail? Having heard or felt this, I said, or I say, maybe it's the moment in which God has taken things in hand and reveals the secret that the world is God. Have you understood that? The world is God. We're all included in all of it. We are all included in it, all of us, just to throw out some thought. So some questions. Do robots think like we do? Answer, no, if someone has fate. Possibly if one does not have such fate. I don't know. I think there are probably quite, I'm quite sure there are a few agnostics and atheists would agree with me that robots do not think like we do. But there may be some people who do think like that. It's usually people who are less informed. I've always found that people get more enthralled by scientific discoveries that the people are least informed. Take the term dark matter, just one minor point. You hear it all the time, and oh, they're working on dark matter. What's that? It's the mysterious matter that fills the cosmos that we don't see, and it's made of neutrinos. I can tell you as a theoretical physicist, having worked in the field, it's very simple. The theory of relativity makes a prediction between luminosity and the radius of the galaxy. That equation does not fit the experimental facts. There's the whole big problem. The experimental observation is very different mathematically to the theoretical prediction. Because it's different, we invent something that must be caused, and it's called dark matter. I've heard it cynically, and I wouldn't disagree, referred to in scientific conferences as the fudge factor. In other words, the numbers don't fix, let's fudge them to make them fix, okay? But how much would you hear about dark matter, something fascinating? The model doesn't work. It's as simple as that. So again, the imitation game. Here would be humans versus machines. You could look at it from a purely secular point of view: computing ability, random number generation, common sense, rationality. And then somebody would suggest the machines are something similar: computation ability, rational number generation, common sense, rationality. That would, I have the reference there, that's coming from a, let's say, a more scientific reductionist approach. And then you could probably have my questions: do robots think like we do? For a person of authentic, for example, faith, Christian faith, even Buddhists, I would argue, or Jewish, the question is meaningless. How can humans communicate to a machine a desire or a quest for self-transcendence? How is it possible for a human being to create an object like his or herself, in other words, in the image of God, if you're a believer? I'm not suggesting you have to be a believer. I was just simply saying that if you have that, you have a different question. In fact, only God can decide to create an object in his image. We instead produce what's called golem. There's a famous book called by Norbert Wiener, From God to Golem. I have it in my office. Norbert Wiener was the founder of cybernetics, and he talks about golem. He does see in cybernetics the science of communication and feedback loops for computers, the possibility of producing something that transcends the human, and he calls it the golem. So it's basically God made in our image and likeness, rather than we made in God's image and likeness. And so if you got the point, we reversed the direction. Now, I wouldn't agree with Wiener, but, you know, I didn't invent the title. There's an atheist or agnostic, like, nor God to golem. Okay, I don't think golem can be. It's a myth. I think we get elements of it in the movies: Superman, Batman, Spider-Man. All those are somehow our human attempts to somehow go beyond and make ourselves better, without simply accepting the reality of who we are. And I think I finished.
Bene, ringraziamo il professor O'Hara anche per essere stato nei tempi. Vediamo se abbiamo proprio un paio di minuti per una domanda, 2 massimo. Se c'è qualcuno in sala o anche nella chat, in web. Queste sono quelle precedenti. Yes. Grazie Valentina.
To speak in English, okay? Because I think this, even though in your PowerPoint there are also some Italian words, but no, just two questions. I think I find a bit uncomfortable in putting together rational, philosophical, or scientific elements together with faith, supernatural, natural, because in that way, if there were here present some people interested in transhumanism but not a believer, I think will find a bit uncomfortable, because I think what you say can be interesting, even though entering into this issue of supernatural, natural, because it's also very human, very rational. Your argument about responsibility, interiority, I found that plus on faith to me is just one impression.
Yeah.
Second very short point. Yes, the final consideration about the image of God, we are created in the image of God. A few months ago, I was in a conference about artificial intelligence. There was a theologian, for me it was a bit surprising, said that now with the computer, we are doing something similar to what God did with us, because we are creating something at our image. These computers, this robot, that is quite biblical in terms of, because we are image of God, but we are not God. There is also the similarity and dissimilarity. And also this something similar can happen also with our machine, that we are imagining a sort of creature that is that is the inversion of Rose. I don't know what do you think about that.
Oh yeah, not
very stupid, but
I'll answer both questions. We'll take the second one first. I think already Manuela Velosa touched upon it, and I would repeat what she said. I think it's absurd to think that somehow we will create something like ourselves with a machine. I think the theologian sees the similarity or parallels. One thing to parallel, it's another thing to actually do it. The very fact that I mentioned Norbert Wiener's book, God to Golem, is exactly that point. We're creating a golem. We're not creating, which is creating something that we think is in our image and likeness, maybe. Whereas the definition as a Christian, and I'm going to answer your first question, would be, or even the Judeo-Christian tradition, is that the human is made in the image and likeness of God. So you have a huge paradigm shift. And why I seriously thought, since you brought up the first point about putting it in, should I leave faith out or not? I think faith defines a bit who I am. And I really don't apologize to anybody for saying I'm a person who has faith. I worked all my life in a very secular environment before coming here. And I think people accept or appreciate if you let them know who you are without imposing it. I think the question of faith has to be confronted if you don't want to be a pure reductionist. Because if you've either got one way or the other. Either you become a pure reductionist, positivist way of thinking, and at the end you got pure, strictly evolution, Darwin. I believe in evolution, by the way, but not strict Darwinism, where at the end natural selection is caused only by randomness or laws of probabilities. Where if you put in, a top-down approach to meet, I could maybe circumvent the language of faith and don't be talking about a teleology, but even that needs clarification, because there's teleologies which are probably not, I would say, coinciding with my viewpoint. But if you put a top-down approach together with a bottom-up, you might get something which is closer to our paradigm. So I think your observation is correct. I did put it in intentionally. I also took out certain things not to be over on it. But I think it needs to be, fronted up about apologizing. I think there are actually quite a couple of people online, I'm sure, are not believers. I'm not trying to impose them, but I'm trying to understand that the question is what defines more important. The question is more important for me than the answer. And it's in getting to the question of who I am that I think you begin to understand the difference between me and a machine, or you and a machine, or you and a computer. But yeah, your point is well taken.
Bene. Siamo nei tempi puntualissimi, professore. Abbiamo recuperato, abbiamo fatto bene.